Hello friends, welcome to our channel again. This is Chem Explain. In this episode, the fourth episode of Organic Chemistry series, we are going to continue our lesson. And as far as you can remember, in previous session we talked about constitutional isomers and we, looked at some examples together. But in this session we are going to talk about the names, how we can name different organic compounds, and specifically how we are going to name the alkanes. Actually, when it comes to organic compounds, they usually have two kinds of names. The first one is called trivial names, and the second one is systematic name. When we say trivial name, we are actually referring to the older names that do not follow any rule, and they are really hard to remember when it comes to a large number of organic compounds. However, the systematic names follow some certain rules and help us to categorize the molecules and organic compounds in a really accurate way. But before we start talking about this, I'm going to say that today, mostly we are going to talk about systematic names. But when we want to use systematic names, we have to remember and memorize the names of the 21st straight-chained alkanes. And look at this table, starting with 1 carbon, 2 carbon, 3 carbon, methane, ethane, propane, and so on. So these are the names of straight-chain alkanes. But you think it's that enough? It's that simple? We can name all of the alkanes that easily? For sure, no, because the main problem happens when we are going to name the branched alkanes. So let's look at an example. Fine. Now, look here. Sorry. So, here we have a chain of carbons that they are connected together, and the second carbon is also connected to another one. So, if we don't look at this part, if we omit this part, it's simply a straight-chained alkane, but when we have it like this, we can say that a methyl group is connected to the second carbon. In this case, any molecule which is like this, or it has a longer chain of carbon, we can easily call them isoalkanes. Or in this case, it would be isopentane. Okay, now let's look at another one. Okay, so again, here we have the main chain of carbons, but instead of 1 carbon, this time we have 2 carbons, or to be more accurate, 2 methyl groups, which are connected to the second carbon. If we have molecules like this, or molecules like this, and longer chains of, let's say, carbons, we can easily call them neoalkanes. Okay, so in this case specifically, we can say neohexane. Now, knowing these two different types of molecules, we are going to start naming the different molecules or alkanes. So let's go. Now, let's take a look at this molecule. Here we have a large number of carbons, and the first thing that we need to do is to find the longest chain of carbons possible. So here we would have this as the longest chain possible. Let's count how many carbons do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in this step we write decane at the end of the name and we go to the next part. So we have the main chain with 10 carbons. However, 2 other parts are also connected. This one and this one. One of them has 2 carbon, which makes them ethyl group. The other one has only 1, which make it methyl group. Okay. Now, we want to add ethyl and methyl to the name. But it's really important to know which one goes first. Look, ethyl starts with E, methyl starts with M. Here, because E goes first in the alphabetic order, we are going to start with ethyl. So, ethyl and methyl. Fine, but we need to tell that which part of the main chain of carbons is connected to methyl and ethyl. Now, we are going to do this like this. Look at the carbon number 3 and carbon number 6. We can say the methyl group is connected to number 3 and the ethyl group is connected to number 6. But maybe you say we can do it in a reverse order. For example, we can say 1, 2, 3, 4, 5, 6. Yes, you're right, but we don't do that. But why? Look, when we have some other groups, such as methyl, ethyl, or anything else which is connected to the main group or to the main chain, we call them substituents. And we are going to start writing the numbers of the main chain in the direction that we get to the first substituent sooner. So here, if we start from this direction, our first substituent would be on carbon 3. But if we started from this direction, it would be on 1, 2, 3, 4, 5. So it's not really ideal for us. Okay, so let's go. Now, which carbon is ethyl connected to? It's 6. And which carbon is methyl connected to? It's 3. Exactly. So the name of this molecule would be 6-ethyl, 3-methyl decane. Now, let's look at this one. So, again, as the first step, we are going to find the longest chain possible, which is going to be this one. Now, we want to count the numbers and we want to write the numbers of the carbons in the correct direction. So, be careful. We do it in the direction that we reach the first substituent in a faster way or in a sooner way. So, it would be like this. 1, 2, 3, 4, 5, 6, 7, 8. Because we have 8 carbons in our main chain, we are going to add octane at the end of the name. Okay? On the other hand, we have a methyl group and an ethyl group as well. So again, because E goes first in the alphabetic order, we write 5-ethyl, then 2-methyl octane. So the name of this compound would be 5-ethyl 2-methyl octane. Now that would be enough, but maybe you're worried if you're not really skillful in this part. Don't worry. In the next video, I mean in the episode 5, we are going to do a lot of examples of naming of different alkanes, so you can get familiar with that. So don't worry and don't rush into it. So thank you so much. See you next time.